Have you ever thought about how you make table salt? I mean, it's delicious, it makes our food taste good, but how do you make it? Let me show you. This is one of my favorite methods.
A small piece of sodium metal is placed in a flask containing yellow chlorine gas. The flask also contains sand to prevent the heat which will be generated by the reaction from cracking the glass. Initially, no reaction is observed between the sodium and the chlorine. The reaction will be initiated by adding a drop of water to the sodium.
Nice. And that is how salt is made. Piece of sodium, chlorine gas, and you get sodium chloride. But what is sodium chloride? What is table salt exactly? That's what we're talking about today. We're talking about ionic bonding and crystal lattices. Lecture 2.2. Ready? Today's learning targets. Here's what we want to focus on. We want to be able to hypothesize compounds that form between ions, 2 and sometimes 3 even. Furthermore, we want to be able to discuss the role that electronegativity and ionization energy play in the formation of ionic bonds. We also want to talk about how to explain how electrostatic attractions lead to the formation of visible salt crystals. We want to incorporate the idea of electrostatic attraction, positive charges, and negative charges. So first things first, how are bonds formed? Electrons and bond formation. Bonds are formed essentially because electrons are moving from one area to another. Sometimes electrons are shared between two things, and sometimes electrons are taken or exchanged so that one atom or another or both can have a full octet. The first one we want to talk about are ionic bonds. And we know a little bit about ionic bonds already because it has the word ion in it. So what do you think ionic bonds are going to be made out of? Yeah, you guessed it. Ions. Now there's 3 different kinds of chemical bonding. Ionic bonding, covalent bonding, and metallic bonding. Today we're going to discuss this bad boy right here, ionic bonds. Ionic bonds are pretty simple. They form between ions as a result of the elements exchanging electrons. One element takes an electron from the other, and it creates ions for both. Because if I have an electron, if I steal an electron, I now have an extra negative charge. If I take an electron away from my friend, she now has a positive charge. I have a negative charge, she has a positive charge. Those two things are attracted to each other. So positives and negatives come together to form an ionic bond. Now this always happens between metals and nonmetals. This is super important. You're never going to get an ionic bond between calcium and sodium, or calcium and strontium, or any 2 metals. Ionic bonds only happen between nonmetals like oxygen and metals like, for instance, lithium. Here's what it looks like right here. Here we have sodium and we have fluorine. Fluorine is going to steal an electron away from sodium because sodium has 1 valence electron. Fluorine has 7, so it only needs 1. So it's going to jack that electron from sodium, take it, keep it to itself, and become an ion. Now over here we have an anion, a negatively charged ion. And sodium is a cation, a positively charged ion. These two positives and positives and negatives, these two charges are attracted to each other, and it forms a bond. We know this as an ionic bond. Now here's where ionization energy, electronegativity come into play in ionic bond formation. Ionic bonds form because there's one atom with a really high electronegativity, a really strong atom, and one with a really low electronegativity, a really weak atom. So what happens is that strong atom is going to come in and steal that away from an atom with a very low ionization energy. In this case, sodium has a low ionization energy. Fluorine is extremely electronegative. Its ability to attract electrons is very high. It's really strong. It's going to steal that electron away from the much weaker sodium. When it does that, it forms the bond, just like this. So what are monoatomic bonds? Well, we know mono means one atomic, so it's between one atom and one atom. So a little bit of element vocabulary before we proceed. There's two things you need to know about elements. We write them like this. They have a subscript and a superscript. They're easy to remember because superscript is like Superman. It's in the sky. It's high up. And this is the number in the upper right-hand corner. So superscript is up. Subscript, like the subway, is below. It's underneath. And that would be the number in the lower corner. So here we have subway in the subscript, Superman for the superscript. They both mean different things. We'll talk about what they are in a second. But the superscript usually refers to the charge, and the subscript refers to how many of them there are. So a little bit about monoatomic ionic bonds. An ionic bond that forms between only two elements, 1 and 1, mono, is known as a monoatomic ionic bond. When elements bond, they form something new. It's become an entirely new thing. We call this a compound. A compound has completely new properties, separate from the two initial elements that came together. And remember that new compounds do not ever have a charge. 0, they're neutral. So let's give this a shot. What's the compound that forms between calcium and fluorine? Well, let's try. We have calcium over here, and the easiest way to do this is to draw out their Lewis structures. Calcium has 2 valence electrons because calcium is in group 2. Just like that. Group 2. Therefore, it has 2 valence electrons. Fluorine, on the other hand, is in group 17 and has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Now, the easiest way to do this is to form what ion they would normally create. So calcium would almost always make a +2 ion. Get rid of this one, get rid of that one. That's 2 less negative charges. Calcium 2+. And then over here, fluorine needs 1 electron. So fluorine is going to become 1-. Now the way to find the ionic bond they form and the compound they'll create is really simple. All you got to do is a method I know as drop and flip. So you take the superscript, drop it, and flip it to the other atom. So that 1 goes over here to calcium and becomes a subscript. So now there's 1 molecule of calcium. 2 flips down and goes over to fluorine. We write that right underneath. And that, my friends, is our new compound, calcium difluoride. 1 calcium, 2 fluorines. And we can just write it, whenever you have 1s, you don't need to write them. CaF2. We have our answer. Easy as pie. Hopefully you can give the other 2 a shot. Just remember the drop and flip. If you want to see answers to this, I have them on some of my other YouTube videos on my YouTube channel. The compound for magnesium and phosphorus, and the compound that forms between sodium and nitrogen. But in the essence of time, we're going to go on to something a little bit more difficult, known as polyatomic bonds. Now, poly means many, a lot. So if it's polyatomic, that means you're going to have more than mono, more than 1 on 1. Now, polyatomic ions are a little easier to think about. They're always stuck together. If I were to take some glue and put it in between Stewie and Brian, they would be stuck permanently. Super adhesive industrial glue. So what does that mean? It's the same thing here. Polyatomic ionic bonds are formed between charged compounds of 2 nonmetals. Now, this happens every now and then. These are known as polyatomic ions. These ions form ionic bonds with other elements from 2 nonmetals coming together and forming a charged compound and taking another metal and putting them together. Let me show you exactly what I mean. Here, we have SiO3, 2-. Now, this right here is stuck together. You cannot separate those 2. So the easiest way to do it is to just write parentheses around them. You keep the charge, the superscript, outside of the parentheses, and it would look like this. We can rewrite it as SiO3, 2-. And see how they're stuck together? We keep them stuck together just like that. Now all I got to do next is take aluminum, find out where aluminum is on the periodic table. Oh, it's in group 3, which means it has 3 valence electrons. 1, 2, 3, which means it would form an ion where it would lose 3 electrons. Get rid of that one, get rid of that one, get rid of that one, and become Al3+. Now we have SiO2- and Al3+. We're going to use our patented drop and flip method. So this guy right here is dropping and flipping. This guy right here is dropping and flipping. And what do you get? Well, you always start off with the metal first, so it would be AlSiO3. And remember that 3 dropped down over here, so we'd have a 3 at the bottom. And this 2 dropped down over the Al, so we'd have a 2 at that bottom. And that right there is our new ionic compound. Between one polyatomic ion that's stuck together and one regular old metal. I hope that helps. And you can give these two a shot between barium and a hydroxide molecule and cesium and a carbon trioxide molecule. Go ahead and summarize that for me for a second before we proceed to the next section. If you want to try the ionic name tag game and the crystal lattice investigation, I think you'll get a lot out of it, because today we're talking about how ions arrange themselves in crystals, or otherwise known as crystal lattices. A crystal lattice is pretty simple. It's essentially what happens when you put a bunch of ions together. They start to stack each other and form repeating patterns. These repeating patterns are known as crystal lattices. Salt, in and of itself, is actually a repeating structure of a very, very simple NaCl. Looks like this. Na refers to the sodium molecule that has had an electron taken away from it, so it's positive. And Cl is this ion right here with a negative charge. Now these positive negatives come together, they're really close, they're attracted to each other. When you stack a bunch of them on top of each other, they form this crystal lattice. They form because of what's known as electrostatic attraction. And electrostatic attraction is when positive ions are attracted to negative ions. And this attraction between the positive and negatives hold these two lattices together. So they all stay close to each other because all the positives are attracted to all the negatives. So it ends up looking something like this. And that, my friends, is our lesson on ionic bonding and crystal lattices. I hope this helps. Please make sure to pause, rewind, take notes as you see necessary. And if you get a chance, try and make some clay models of crystal lattices before proceeding on to this exit ticket. I hope this helped. Closing time. Take care.